Sixth grade lesson 7.8 is generating equivalent expressions. And this is a lesson where we're still dealing with those combining like terms, but they're going to show us some properties of addition and multiplication that become useful to us. And we learn the names of them. We repeat the names of them over the years, but a lot of times we just do these properties out of habit because we get used to them. And we kind of just do them sometimes in our head. But for a while, they're going to show you these operations or these properties occurring, and then and we'll name them just so that it kind of gets into your head, so you remember I am allowed to do this. So let's get started. They talk about equivalent expressions, meaning expressions that will come out equaling the same thing. For example, if I have x plus 3, that's the same as 3 plus x. I can prove that by choosing a number for x. Let's say I choose 4 and plug it in for x on both of those expressions. 4 plus 3 is 7. Oh, I did that backwards. Okay, there, I fixed it. 4 plus 3 is 7. And then this 3, I had reversed these 3's, and then we had substituted 4 for x. So 3 plus 4, of course, as you know, is 7. So in addition and multiplication, we know because of experience over time that you can swap those around and it's not going to affect your answer that comes out. So if you're adding two numbers, you can flip them. Let's say you're adding 2 plus 3. You can add 3 plus 2 and get the same thing, right? So we know that if it's an unknown variable, if I'm adding 12 plus a, it would be the same as a plus 12. Or if I'm multiplying 9 times d, that's the same as d times 9. So that is called the commutative property of addition, if it's addition, and multiplication, if it's multiplication, commutative property of multiplication. So we can, it just says, hey, you can flip these around. If it's addition only, or if it's multiplication only, you can move these around, and that's okay. The other property they tell us about is the associative property. Again, this is only works in addition, and it only works in multiplication. I think of these like middle schoolers. It's your regrouping. You know, sometimes we're friends with these guys, and then now we're friends with these guys. And what it's saying is, if I'm only dealing with the operation of addition, then I can regroup this, and I can say, hey, you know what? I really want to hang out with these guys instead. So notice I did not move my numbers like the commutative property said, hey, it's just addition, you can go wherever you want. I didn't do it in this circumstance. What I did was I regrouped what I'm going to handle first. So instead of handling 8 plus b first, because I can't, because I don't know what b is, I'm going to handle 5 plus 8 first. This was 5, 8b, 5, 8b. The order is still the same. I just said, hey, instead of doing that first, I'm going to do that first. I'm allowed to do that because all of my operations are addition. If they were other than addition, then I would have to follow my order of operations. This also works, this is called the associative property of addition, but this also works in multiplication, the associative property of multiplication. And so if we get an expression that has just multiplication in it, and I want to rather do this first than this, where the parentheses say, I'm allowed to regroup it and say, okay, I'm just going to do this first, and then I'll do the other. Now, again, if there were other operations in there, subtraction or division or something else, then I can't just go ahead and move those around. But because my only operations were multiplication and that was the only thing, then I'm given a little more freedom to do one thing before the other. So this one, where I don't move the numbers, I just decide a different order I want to calculate them in, is called the associative. And I remember this by, oh, I want to hang out with this group today. Never mind, I want to hang out with this group today. That middle school thing. Who do you associate with? It may change while you're in middle school. So finally, the other property that they teach us is the identity property of multiplication and the identity property of addition. Think of your own identity and your name. What do you add to your name so that it stays the same? If your name is 12, what can I add to 12 so that it remains a 12? The only number I can add to 12 so he remains a 12 is 0. And so in addition, The identity property is you add 0 to anything, he maintains his name. In multiplication, what number can I multiply 12 by in order for him to stay 12, to maintain his identity? 1, right? The only number I can multiply 12 by where he would maintain his name, maintain his identity, is 1. So anything multiplied by 1 stays the same, and that is known as the identity property of multiplication. You've been doing these properties for a long time, but now you're applying a name to them as a reason for why I can move these around. So let's look at some examples. And again, this is from the page in your book. This is just the breakdown of the three properties they talked about. The properties of addition, commutative property of addition. I can swap these. This was 12 plus A plus 12. Associative property, I can just regroup them. Instead of doing 8 plus B first, I can do 5 plus 8 first. And identity property, 0 plus C, well, C added to nothing is still going to be C. He maintains his identity. Same for multiplication, commutative property of multiplication. D times 9 will come out as the same answer as 9 times D. Associative property of multiplication, I have 11 times 3 times E. My only operation is multiply. So if I want to regroup and do 11 times 3 before dealing with the E, I can do that. And the identity property of multiplication, 1 times F. F will maintain his identity because anything times 1, it maintains his identity. He will still be F. Okay, so this unlock the problem just kind of shows you the walking through of the properties happening. Now, generally, as you get further along, you do these steps. You can use these properties to your advantage, but you don't kind of sit down and explain, oh, because of this, oh, because of that. So, but here, just so you can get used to why we're allowed to do it, they're going to show us that. So we start off with the expression 2 plus 3L plus 5. We have 2 plus 3L plus 5. And we have these two like terms here, right? Remember that from previous lesson? Here's 3L. It's not a like term. In your mind, you can say, okay, let me just add those two together. But they're showing us the steps for your brain to see it so that you can understand why we're allowed to do that. So we're going to move these around. And when we move these numbers around, because the only operations here are addition, we can do this. I'm going to move this 2 to be next to this 5. And so we have the two like terms of 2 and 5. And we're going to use the commutative. You know, you go to work, you commute to work. Well, that's moving from home to work. We commute the 2 over next to the 5. We're allowed to do that because of the commutative property of addition. Then instead of doing 3L plus 2 first, I want to regroup and I want to have this one happen first. This addition happen first. I'm allowed to do that because it's all addition, doesn't matter. And the regrouping is who it associates with. The associative property regroups things. So we're just going to put parentheses around this 2 and 5 so that we can say, hey, I want to do that first. That's what I feel like doing first. We're allowed. And then we add those together. And the equivalent expression for this expression, oops, not that. Sorry. For this expression, simplified, is 3L plus 7. A simplified expression is an equivalent expression, or else it wouldn't have matched. So there is that. Okay, another property they teach us, and this is a big one that you use a lot as you go further into into 7th grade math and 8th grade math. My 7th graders and 8th graders are using distributive property. They're very comfortable with it now, but it took them at first the time that your brain's going to take to kind of figure out what's going on. And so if I have an expression that says 5 times G plus 9, two operations, right? So I can't just go moving things around. This means this is 5 times these two put together already. My problem is I can't add G plus 9. I don't know what G is. So a workaround to that is to multiply 5 times both terms inside of there. I can do that, and that's called the distributive property. I wrote this over here looking like this because most of the time you'll see this expression looking like this. You'll become comfortable with the fact that the number next to the parenthesis is an automatic assumed multiplication. So this is 5 times everything inside. So we can rewrite this as 5 times G added to 5 times 9. 5 times G added to 5 times 9. That 9 looks like a G, doesn't it? Let me fix that. Okay, there we go. All right. That's 5 times G plus 5 times 9. And usually we just kind of, instead of writing it out, we just say that's 5g. 5 times g is 5g, and 5 times 9 is 45, and that's the steps you'll get to going to. But they're breaking it down for us nice step by step. We're doing 5 times g plus 5 times 9. I'm going to go ahead and calculate my 5 times 9, which is 45. And 5 times g is just 5g. These are not like terms. I cannot add them together. So that's as simplified as I can get. That's the distributive property, is distribute in a number outside. Now, there is the reverse of the distributive property as well that they'll be talking about also, and that's pulling a greatest common factor out of it. I think they get to this in the in one of the examples, so I'm going to wait and I'll come back to it if they don't. All right, so we're going to use the properties of operations. Remember, those properties are the commutative, the associative, the identity, and then we learned the distributive just now. We have 5a plus 8a minus 16. This is the expression they wanted us to do. We can use the, and so remember what this really means is that's 5 times a, and that's 8 times a, and then minus 16. So they're saying let's use the commutative property to kind of separate these out. This one is a times 5, so we flipped those around, 5 times a, 8 times 5, either way, right? And this one is 8 times a, or also known as a times 8, okay? Then they want us to use the distributive property to rewrite a times 5 plus a times 8. This is where they get into that distribute out sort of scenario. I guess I should have covered that in the first slide. Let me explain distribute out real quick. We have a common, it's sort of like when you have reduced fractions, same idea. I'm going to use numbers to do this, and I'm going to use the same ones that we saw, that 5g plus 5 times g plus 9, like we saw in the previous slide, that we said is the same as 5 times g plus 5 times 9, the multiplication of everything, the 5 times everything inside of the parentheses. So we ended up with 5g plus 45. A lot of times, big mistake to watch out for. People forget to do the second term by that 5, so don't forget that. You'll see in the questions that they try and catch you on that too, when you get to the independent practice or the on your own. So that was distribute in, as I mentioned before. You can distribute out to simplify things too sometimes, to return it to this sort of scenario. The way you do that, very much similar to when you reduced fractions. You look for a number that divides equally into both of these terms. Well, I know that 5 divides equally into 5 and also can divide equally into 45. So I can say I'm going to divide 5 out of both of them. And if I divide 5 out of both of them, I'm pulling 5 away from both of them. So I'll put 5 on the outside, and 5 divided by 5, let me say that better. 5 divided by 5g just leaves me with 1g. And 5 divided by 45 divided by 5 is 9. Wow, I'm just off my game here. Is 9. And here I've returned to this. So you're just manipulating these numbers to work in a way that you need them to work for you. The distributive property doesn't get you an answer. It just gives you the chance to get it. Like here, I needed to work around because I don't know what G is. So I needed a workaround. That gave me my workaround. But sometimes I want to simplify it so it's a little cleaner. And I'd rather that something like this look more like this. And you'll see as we go further along that that happens, that you need it this way. Oh, but I need it this way. And so you become pretty adept at distributing in, and also you become pretty adept at distributing out, just to get them the way you need them to look. Now, returning to here, that's what they did here. They used the distributive property to distribute out. We were doing a times 5, and then we were also doing a times 8. The commonality was the a. So we said, hey, let's pull that a. Let me put that a different color. There we go. Let's pull that common a, and we're going to do a times 5 and a times 8, but we're going to write it this way instead. And then I can go ahead and add those two commonalities together. 13. Now, you've already kind of been marrying those like terms. You might have already just taken the step and said, this is 5A's, this is 8A's, put it together, it's 13A's. Okay, that's true. And that's what we end up getting is 13A times 13. And they say use the commutative property of multiplication, meaning I can flip those around. 13 times A, also known as 13A. So the expression 13A minus 16 is equivalent to 5A plus 8A minus 16. And so in this lesson, they're going to start asking us, are these equivalent or are these not? And we're going to kind of test it out to see. So here we have, on example 2, we have the expression 6 times y plus 7. This is that distribute in thing. We would use the distributive property. This is 6 times y, and 6 times 7. 6 times 7. And I can do, because I know what this is, I can do this. 6 times 7 is 42. And so the expression 6y plus 42 is the same as 6 times y plus 7. These are equivalent. If you plug in a number for y, you're going to get the same answer on this one as you would on this one. That's what they mean by equivalent. Now they're looking at the distribute out scenario, 12a plus 8b. And so just like when you're reducing fractions, you're going to kind of take that same idea, that greatest common factor, the factor that can divide evenly into both of them. And you want to use the largest one. We want to get it as small as we can. So I'm looking at this, and yes, 2 divides equally into both of them. 3 does not. 4 does. 8 would here, but not here. So 4 looks like it's the highest number that will divide evenly into both of them. That's the greatest common factor. So I'm going to take that 4 out. And I'm going to, so I've got this 4. And now I'm going to look at this 12a. 12a divided by 4 is going to be 3a. And add that to 8b divided by 4 is going to be 2b. And that's what we get there. 4 times 3a plus 4 times 2b. And so what we get with that distribute out is 4 times 3a plus 2b is equivalent to 12a plus 8b. So if I plug in an answer for a on both of those and an answer for b on both of those, I will come up with the same results to both. And that's what's happening. And I know a lot of that feels like, why, Miss Sanchez, why are you making me do this? These are manipulations that you will utilize as you go further in math. So the introduction of them now and the little bit of practice you'll do will benefit you later. Sometimes I need my expressions to look this way when I'm calculating, and sometimes I need my expressions to look this way when I'm calculating. So being able to go back and forth is important. Use those skills on your share and show, and you're on your own. I think you'll do great.